Hello and welcome to zero exponents and negative exponents. I have up here a chart. You might want to pause right at the beginning and just copy this down. But I'll start talking now and you can pause as you want. You see that 2 to the 4th is 16, 2 to the 3rd is 8, 2 squared is 4, 2 to the 1st is 2. What's happening each time? What's the difference between 16 and 8? Well, it's being divided by 2, right? Divided by 2, divided by 2. If I divide by 2, again, 2 divided by 2 must be 1. Well, what's happening here? 81 to 27. Divide by 3. Divide by 3, I get 9. Divide by 3. Divide by 3. 3 divided by 3 is 1. Divide by 4. Divide by 4. Divide by 4. 4 divided by 4 is 1. This pattern will happen no matter what, even if I keep going on to really big numbers. And what it shows is that really if I have anything to the 0 power, it will always be equal to 1. Now let's keep going. Okay? 3, 2, 1, 0. What about negative 1? Well, if I divide this by 2, 1 divided by 2 gives me 1/2. If I go again, another. 1/2 divided by 2, I'll cut that in half. Cut that in half. 3 to the negative 1, 3 to the negative 2, 3 to the negative 3. These are being divided by 3. So if I divide this by 3, divide this by 3, 1/9. 1/27. Same thing here. Divide by 4. Divide by 4. Divide by 4. So if you see our pattern here, 2 to the 3rd, 2 to the negative 3 equals 1/8. Isn't 8 the same as 2 to the 3rd? So 1 over 2 to the 3rd equals 2 to the negative 3 power. If I look at this one, 3 to the negative 3 is 1 over 27, which is 1 over 3 to the 3rd. 4 to the negative 3 equals 1 over 64, which is 4 to the 3rd. So if you see the connection here, the negative exponent means the positive exponent in the denominator. Negative, positive, negative, positive. So it looks like any negative exponent means the reciprocal of the positive exponent, putting it in the denominator. So a to the negative b power looks like it equals 1 over a to the b. Here's a proof. It's another way to think about it. 2 to the 2nd over 2 to the 2nd. Well, we know 2 to the 2nd is 4. And 4. And anything divided by itself is always 1. So let's think this way. You know the division rule now. When you have exponents, when you divide, you subtract. So this means 2 to the 2 minus 2 power, which is 2 to the 0 power. So anything 2 to the 0 must equal 1. Something to the 0, now we can connect back and say that must equal 1. What if we have this? 2 squared is 4. 2 to the 3rd is 8. 4 divided by 8, 4/8 reduces to be 1/2. Using our rules of exponents, we know this is 2 to the 2 minus 3 power, which is the negative 1 power. So 2 to the negative 1st equals 1 over 2 to the positive 1st. So the negative exponents are reciprocals. That's a key word, reciprocals. Let's look at it if we have a negative exponent in the denominator. Well, we just learned that 2 to the negative third is equal to 1 over 2 to the positive third, which is 1 over 1/8. And this is 1 divided by 1/8. Here's another way we could write it. You might remember from dividing fractions, you have to multiply by the reciprocal. And 1 times 8 equals 8. So this is equal to 8. And we know 8, if we're looking at 2's, is 2 to the third. So 1 over 2 to the negative 3 is the same as moving this negative 3 into the numerator and making it 2 to the positive 3 over 1. So we can put this together. Or even more, 1 over a to the negative b is equal to a to the b. That's another important rule. So when you see a negative exponent, flip it to the positive exponent. It's really just like reshuffling the furniture, downstairs to upstairs. If we've got negative exponents in the top, move it to the bottom. If it's in the bottom, move it to the top. So a problem like this. First, we can deal with the 6 and the 3. 6 divided by 3, that's just 2. So we'll put that in the numerator. Now let's change any of our negative exponents. Here's a negative exponent. Let's move this one downstairs. Here's a negative exponent. Let's move this one upstairs. This one's positive. It can stay here. It doesn't have to move. This one is x to the first. It was positive. It can stay put. Now we can figure out the rest of this. This is going to be y to the 8th in the top. And this is going to be x to the 3rd in the bottom. One last example, something like this. X to the negative 3 times 5 to the negative 2 times x squared. X to the negative 3, let's change that. That means right now it's in the numerator. We need to drop that into the denominator. So let's put this down in the bottom. 5 to the negative 2 needs to come downstairs, make it 5 to the positive 2. And x squared, well that's positive, so that can stay up high. So here's this. Now let's figure out what to do. 5 squared, we know that's 25. It's going to stay in the bottom. And our x's, 2 of these cancel with 2 of these, leaving 1 left. So we've got 1 left. Should we put a 0 on the top because it's all gone? No, remember, it's always 1. So we've got 1 over 25x. I hope that was helpful. Have a nice day.